Usually in 3-day events, usually, the first day is the most important, last day is most important. We break this rule. Second day is most important. So welcome to second day of our workshop. I really look forward for the enriched plan or schedule. We're starting with a very interesting lecture, probably something that one of my favorites, but after that, we'll have a lecture by Dr. Iorio, and I would, in no means, I would miss this lecture as well. The 2 small tutorials are very interesting. They should be light. They shouldn't be cumbersome to you, but they should be light. And the last lecture is very interactive, and I would highly recommend that you stay tuned, keep your attention at that lecture, because I really look forward to it. So back to my probably something that I would look for every year, our invited resident or fellow. So this is where usually every year we have one of the residents or fellows to present to us a life example of applying evidence-based clinical practice. And this year, as I introduced to you Dr. Yasmin yesterday, gave you a little bit of background about her. She's a second-year fellow in the program of clinical immunology and allergy. Yasmin is going to talk to us about how to apply EBCP, evidence-based clinical practice, into clinical practice. Yasmin, the floor is yours.
Can you hear me? So, thank you, Dr. Fahed. We're going to talk about how to apply evidence-based clinical practice with an example. So this is just application of what you guys have done yesterday. And try to keep it interactive, try to answer. I'll try to include you as much as I can. So we're going to start with a question that a resident has. We're going to look at the PICO, hopefully you guys remember, and how to look for and find the evidence, just quickly go over that, and then look at the types of studies out there, do the internal and external validation, or validity, sorry, and what do the results mean? So answering the question in the end. So we have an R4 who joins the trainee for rounds, and she says, this is my 5th coffee and we haven't even started rounds yet. And the trainee says, you drink so much coffee, it's going to kill you. Now, what do you guys think? What is the evidence that too much coffee will kill me? What do you guys think? Show of hands. Who thinks too much coffee will kill you? Nobody. Okay. So let's answer the question using evidence-based practice. Now, can you guys identify the PICO here? Or PICO? So what's P? Okay, good. What's I? And C? And O? Okay, so what's the P here in this scenario? Adults, okay. Anything else you guys can think of other than adults? Specifically, who are they? Healthcare workers, coffee drinkers maybe. Okay, what's the intervention? Coffee, drinking coffee. Comparison? Again, what are we comparing? Okay. And then the outcome? Death. So, good. So we have our question, and now we need to do a search. So this is just a revision. You guys know we start with a question, we do a search, we appraise the study that we're doing. So we look at its validity, the results, and how applicable they are, and then we apply it to our scenario. So finding the evidence, and you guys are going to get a couple more talks about this, but when we search for evidence, we have to think of this pyramid, and we go from, quality of evidence, higher quality of evidence down. And on the top is always systematic reviews, meta-analyses. These are always the best studies. Not always easy to find, but these are the top. And then you go down, and this pyramid shows you the different search engines that we use to come up with the different quality of evidence. So we think of randomized controlled trials, although there's randomized controlled trials with the cohort studies, so they've grouped them as one, but of course there's a difference even in between in each of these lines. So then we look at what type of question are you asking, so, and what will the evidence support? So there's 4 main categories here. Do you guys remember, or have you guys come across the 4 questions? So we look at therapy or treatment questions. We look at the evidence that supports how to select treatments that you could offer your patients. So that's one kind of question. And then you have a diagnosis question, which is how to select and interpret diagnostic tests to confirm or exclude the diagnosis or disease. And then you have a prognosis question, which you're looking at evidence to support how to estimate your patient's likely clinical course over time will be. So that's the third. And then you have a harm or etiology question, and you're looking at evidence to support evidence that supports how to identify causes for disease or death. So what kind of question do you think we're looking at? Okay. So harm, which we're ascertaining the effects of potentially harmful agents. In this example, it's coffee. And so what next? Now we know we've looked at the question, we've gone into detail. What do we do next? How are we going to answer it? So we're going to do a search. And most of us go into PubMed. And we type in coffee consumption and mortality. Again, you guys are going to do this and have a talk about the best ways to do the search and how to narrow it down, how to do an advanced search. Are you guys familiar with these tabs here on the left-hand side? Yeah, how to narrow it down even more. So that's what we did. We put coffee consumption and mortality and looked through the papers. And then we saw New England Journal of Medicine. Everyone always loves the New England Journal of Medicine. So we found this paper, Association of Coffee Drinking with Total and Cause-Specific Mortality from 2012, so fairly recent. And it looked like it fit. So let's scan the question. Let's compare our clinical question to this study's PICO question. And just looking at the abstract, we can see the P, right? So they looked at this number of men, this number of women, so this is our population, and they were 50 to 71 years of age. They looked at the comparison of coffee consumption, and then the outcome was mortality. So what do you guys think? So this is the article that we chose. Again, what type of study is this? Does anyone know? Cohort, good. And so we're looking over time or watching over time. What kind of cohort study is it? Observational cohort study, okay? So we're coming up to appraising the study. So we have, the cohorts are made up of these individuals, 50 to 71 years of age, and they were followed for 14 years. They returned questionnaires, that's how they followed them, assessing their diet and lifestyle. In America, they included 229,000 men, 173,000 women. They excluded those who didn't complete their own questionnaires. They excluded those that were diagnosed or had been diagnosed with cancer, heart disease, stroke. Yeah, I mean, obviously, at the time of that the questionnaire was sent out. And they looked at coffee consumption, along with other things, according to 10 frequency categories, so ranging from 0 to 6 or more cups of coffee per day. And then they followed them until their death or until December 2008, whichever came first. They used periodic questionnaires and they used the death registry. And we specifically will look at hazard ratios and confidence intervals from the study and look at the mortality associated with coffee consumption. So doing our critical review for harm, there's this is part of the package that you guys either are or will be familiar with. And this is table 1. So I'm sure you guys have talked about table 1. So this, when we look at it, we're looking at all the groups and ensuring that baseline characteristics are similar. So our groups here are no coffee, and then different numbers of coffee in consumption of coffee in men, and then the same in women. And then you have demographics or characteristics down here. So let's look at diabetics. So across the board, diabetics, similar numbers, right? So we're looking at, with that characteristic, in each group, you have a similar number. We move on to internal validity. So what are we looking at when we look at internal validity? We're looking at the risk of bias, right? We're within the study. And the questions that we look at. So, did the investigators demonstrate similarity with respect to all known outcomes, which is the same as what we just did, you know, looking at the table. And then, were the outcomes and exposures measured in the same way in the groups being compared? Where would you find this answer? So, basically, measurement in the groups. When we want to know how things were measured, where would we look in the article or in the study? Methods. Okay. So we're comparing here coffee drinkers to non-coffee drinkers, and they looked at questionnaires over time. So again, moving on with internal validity, was the follow-up sufficiently complete? So were people dropping out? Was the sample size affected? So when this study had a cohort follow-up part of the article, and they talked about how they used the postal service, they used death registries, different ways to follow up the patients to see what happened to them. So that's internal validity. When we're looking at characteristics, they found, just kind of from the different characteristics, that coffee drinkers were more likely to smoke cigarettes, consume alcohol, eat more red meat, have a lower level of education. This was based on their population, on their patients. Less likely to engage in physical activity, lower levels of healthier food. In those that consumed more coffee, so higher number of cups of coffee. And you can see here in the smokers, so the numbers or the percentage of those that drank no coffee versus the ones that drank more than 6 or more cups of coffee. And same in women. So this is men and this is women. So moving on to external validity. So anytime we talk about the strength or association between two exposures and outcome, what are we looking at? So, association between exposure and outcome. Does anyone know? It's a ratio. Sorry? Hazard ratio, exactly. So, we're looking at the hazard ratio here in this study. And then when we say we want to know how precise is the estimate of risk? Confidence interval. When you hear precise, you think of confidence interval. Exactly. So here are the hazard ratios. So here are the results, including the hazard ratios for men who drank versus didn't drink, and then in each category, the number of cups. So you have your hazard ratio here usually, and then you have your range for your confidence interval. And then the same for women. And then does anyone know what this chart is? Forest plot, okay. So here, so usually you see forest plots in meta-analysis or systematic reviews, and each of the lines would be the study, for example. Here, what they did was they have one for men, one for women. The line is 1, hazard ratio 1. What does hazard ratio 1 mean? Okay, good. And you can see that these dots are under 1, so most of the groups were less than 1, and same in the women. And so these are the hazard ratios for death from all causes, and they compared those that drank 4 or more cups of coffee versus those that didn't drink any coffee. And then, of course, your horizontal lines represent your 95% confidence interval. Okay, so what does all this mean? So just to recap, if you have a higher hazard ratio, what does it mean? Higher what? In our case. Sorry? Death, higher mortality, good. So hazard ratio is the ratio of the probability of an event, and in our case, death, in the experimental arm, which are the ones that are drinking the coffee, to the probability in the comparator arm, and that's our non-coffee drinkers. And confidence interval is a range, and the narrower the confidence interval, the more precise the study. We know that, and as that confidence interval widens, there's uncertainty about the magnitude of the effect. So when our confidence interval crosses no effect, so relative risk 1, there is uncertainty about the effect of intervention, like we said. And you always remember the confidence interval, this is how I remember it, is if you repeated the test or you repeated the study 100 times, 95% of the time, we will be within that confidence interval range. And it indicates your sample size, basically. So here, when we look at the results again, you see that you hit 1 quite a few times here. So although the confidence interval is not large, we have 1 within the range. And this is the second table that they put up there, and it just shows you the same thing, your numbers. And from this table, they came to their conclusions, which were that men who drank 6 cups of coffee. Now, we just saw that the hazard ratio here was 0.9. So the conclusion that you can make from that is men who drank 6 cups of coffee or more in this study per day had a 10% lower risk of death from all-cause mortality, not broken up into the groups. And then for women in the same category, more than 6 or more cups of coffee had a 15% lower risk of mortality, all-cause mortality. And it was similar, they broke it up into decaf versus caffeinated, and it was similar for both. Now we move on to applicability. So how can we apply this? Were the study patients similar to our patients or our population? No, because? Yes, so most R4s are not 50 or above. So was the duration of follow-up adequate? So it was 14 years. So it was good number of years. So the youngest patient in this study was 51. And then when they finished, they were 65 years old. And we're looking at mortality. So it's important to think about that. Now we look at confounders. In observational studies, the associations could reflect unmeasured or poorly measured confounders, right? Because it's not a controlled study, it's observational. So you're sitting back and you're watching. And coffee consumption was inversely associated with diabetes. That was one of the things that came up. It was positively associated with unhealthy behaviors, like we said. And again, looking at the limitations, one big thing that this study showed was that, or that they did in this study, was they only looked at coffee consumption at one point during those 14 years. So they sent out a questionnaire and they asked them, how many cups of coffee do you drink? And then they didn't ask them again. Then they looked at causes of death and death. So they didn't reassess if that had changed. So that's a big limitation. And then they talked about in the paper the way the coffee was prepared could have made a difference. I'm not sure if that's significant. And then the inverse association between coffee consumption and mortality is stronger in the never smoked or former smokers. Again, smoking is a big factor here. Persons with chronic disease and poor health might abstain from drinking coffee. Those who exercise might drink more coffee. And then there are other possible mechanisms by which coffee consumption might have health benefits. So there are other possible factors here that are not taken into account. So what can we conclude? What do we tell the trainee from this study, at least? So they said that men who drank 6 cups had a 10% lower risk of death. What do you guys think? Is there strong evidence for this? Is this enough to come to that conclusion? Even given all the confounders and the limitations and the things that, we probably didn't even think of. We could safely say that the study provides some reassurance that coffee drinking does not increase mortality. So we don't have any evidence that you will die if you drink more coffee. But we probably need to do more research and more to come to a stronger conclusion. Does anyone have any questions? Okay, thank you. Yes.
So can we get rid of this kind of confounding this cohort, the analysis of it?
We can look at, so they only looked at current, former, and non-smokers. So they had those divisions. So what we can do is we can compare each of those groups. And again, in non-coffee drinkers versus coffee drinkers. So you can use the data that way. I don't know if, yeah, I mean, yeah, exactly. Yeah, that's the only way you can really do it. Anyone else?